Today, I'm going to show you how to do lighting in the Vertex shader. Let's go! So last week, I introduced this new series of videos on custom lighting models. And what I decided to do was to start out with the most basic lighting and work our way up to more advanced. So today, I'm going to show you how to do Vertex lighting, which is the simplest type of lighting. And then in future videos, I'll show you how to do more complex and realistic lighting. So way back in 1999, the first couple of games that I worked on used Vertex lighting. Back then, lighting was done per vertex because that was the only thing that the hardware could handle. Doing anything per pixel was unheard of. There was no graphics hardware that could do that. GPUs didn't exist back then, and so 3D rendering had to be done directly on the CPU. We obviously have much more advanced graphics hardware now, so why would anyone want to do Vertex lighting today? I can think of two reasons. First, you might do it if you want the absolute most optimized shader possible, and it doesn't bother you that the results are lower quality. Maybe you're making a game that has to run on an extremely low-end device. And the other reason that you might want Vertex lighting is if you're going for retro style. If you want your game to look like it's running on the PlayStation 1, to have that super old school look, then Vertex lighting is a good way to achieve that. Alright, let's jump right in, and I'll show you how to do lighting in the Vertex shader. So we're going to start out in Unity today, and then in just a minute I'm going to jump over to Unreal, and I'll show you how to do Vertex lighting there as well. So we're just starting out with a very basic scene. I've just added a plane and a sphere to it. And I made a new folder in my project window down here called Lighting, which is where we're going to put all of the content for this series. So I'll just right click in here and pick Create, Shader Graph, URP, Unlit. And it's very important that we create an unlit shader here because we're telling the engine, I don't want to use your lighting, I'm going to make my own. So we created an unlit shader, and I'm just going to call this Vertex Lighting. And we'll open it up and get started. So here's my new shader, and you can see on my master stack here, I've got my Vertex shader, and I've got my fragment or pixel shader. And so the lighting that we're going to be doing today is in the Vertex shader. Now, I want to keep things kind of organized, and so what I'm going to do is create a subgraph. So I'll come back down here to my lighting folder and right click and pick Create, Shader Graph, Subgraph. And I'm going to call my subgraph Vertex Lighting as well. So there's my subgraph, and I can double click that. And so this is where I'm going to create the actual shader. The first thing that I want to do is pick my output here, and I'll open up my graph inspector, and I'm going to rename the output color, and I'm going to set it to be a vector 3 because my color is RGB. Alright, and now the first thing that I'm going to create in the lighting is the ambient light, and so I can add a new node here. I'm going to add the ambient node. And it has three outputs here: color, sky, equator, and ground. And we're going to use these other outputs in a minute, but for now, I'm just going to directly wire the color sky output to the color out here of my subgraph. I'll save the result, and then I'll switch back to the shader that we created at first. And I'm going to drag and drop my Vertex Lighting subgraph into my shader. So I've got this very simple shader that just outputs a color, and I want to pass it into the Vertex shader. So what I need to do is click here on my Vertex shader component and hit the space bar and pick Custom Interpolator. And that's going to give me another input node here that I can pass my value into. Now right now this Custom Interpolator block is a vector 4, and it's just called Custom Interpolator, and I want to change it. So I'm going to open up my Graph Inspector again. And for the name here, instead of Custom Interpolator, I'm going to call it Color. And for the type, I'm going to set it to a vector 3. And now I can just connect my vertex lighting directly to color. And now I'm passing my color data that I've created into color here. All right, and now in order to get that output, I need to add my custom interpolator node down here and pass it into my color output in the fragment shader. So you can see that what I'm doing here is I'm calculating that color, passing it into the vertex shader, or I'm doing the calculation in the vertex shader. Then I'm interpolating it to the pixel shader, and then I'm passing it out to the pixel shader there. So let's go ahead and save this, and we'll assign our shader to my scene here. We're going to assign vertex lighting to the plane and vertex lighting to the sphere. And you can see now I've got this kind of bluish color. And you might be wondering, well, where is that color coming from? Let me show you that really quick. So if I come here under Window, and I pick Rendering Lighting, and then I switch to the Environment tab, you can see I've got this environment lighting source, and I can choose what kind of a source I want my environment lighting to come from. Here I'm going to pick Color, and now you can see the color that's being used for my environment, for my ambient lighting. So if I pick something different for this ambient lighting here, let's make it yellow. Now you can see that my scene is turning yellow, and that's because this color here is being fed into the ambient block here and coming out there. So whatever color I set in the lighting window is the color that's going to show up on my model because I've passed it into my shader and then out to my model. All right, so we've got our very most basic vertex lighting shader here. All it's doing is ambient light. Well, what if I want to get a little bit more advanced and I want to use these other values here? Let's go ahead and set our ambient lighting, instead of color, to use gradient. And now it's exposed 3 values. I have a sky color, an equator color, and a ground color. And I'm going to put this window over here just so we have easy access to it. Let's go ahead and create an implementation that uses those 3 colors. Let's just do 2 colors at first, actually. So we'll open up our blackboard here, and in order to use these colors, I need to add a normal. So I'm going to create a new vector 3, and I'm going to call this normal WS. And that WS on the end stands for world space. And I want to create a default for my world space normal input. And so I'm going to check this use custom binding box, and we're going to give it a label of normal WS. And now I'll drag in my input here, and we'll create a default for it. So I'm going to create a branch on input connection node and connect it up to the input and the connected. And then for the not connected, we're going to create a normal vector. So this is a vector that represents the direction that the surface of our model is facing. So we're going to use that direction that the model is facing to determine which color of our ambient gradient to use. We have our sky color, our equator color, and our ground color. And for our normal here, what we want to use is the the Y component of our normal. So there's our Y, and you can see that our Y is the up direction. It determines whether or not the surface is facing up or down. So up here at the top, if the surface is facing up, that Y of our world space normal vector is giving us a value of 1. And down here at the bottom, if the surface is facing down, it's giving us a value of -1. And so we can use that value to blend between the ambient colors. So let's go ahead and do that. I'll create a lerp node, and we're just going to use two colors for now. We're going to use the sky color, which I'll pass into the B of our lerp, and we have the ground color, which I'll pass into the A. And whatever I connect to this T value is going to blend between the sky if the T value is 1, and it's going to blend to the ground if the T value is 0. Now, right now, we know that our Y value here goes from 1 to -1, and we actually only want it to go from 1 to 0. And so we need to adjust it a little bit. So what we're going to do is we're going to multiply that Y value by 0.5, and then we're going to add 0.5. And what we've just done by doing this is we've adjusted the range. It used to go from -1 to 1, and now it goes from 0 to 1. So if I connect this up and pass that to our output color, now we're blending between our sky color and our ground color. And if I save this, and we take a look over here, now we have a little bit brighter color up here on the top, and a little bit darker color down here at the bottom. And it's not super obvious, so let's just go ahead and adjust this a little bit so you can see what's going on here. Now, normally I wouldn't use ambient lighting that was this bright, but just so that you can see the results, you can see that now we have our ground color down here and our sky ambient color up there. So, pretty cool. You can see that our ambient color is being applied to our plane, and we're just getting the sky color on the plane because the plane's pointed straight up. But on our sphere, where we have normals pointing up and down, you can see that we've got this nice blend between our sky color and our ground color. Well, let's get just a little bit more advanced. And what if we want to incorporate our equator color in there as well? So let's go ahead and do that. So we have our sky color and we have our ground color, and we're actually going to need to add two lerp values for this one. So there's our first lerp and our second lerp. And what I'm going to do here is I'm going to connect the ground value to the first lerp and the equator value to the B of the first lerp. And then we're going to connect that to the second lerp. Instead of the ground, I'm going to connect the blend of our equator and ground. And then we're going to leave our color sky connected to B there. Okay, and now we're going to do this blending a little bit differently because we need two values. We need to blend one for our first lerp and one for our second lerp. And so I'm just going to take the output Y here, and just like we did before, we're going to multiply... Oh, okay, so I'm going to take the output of the Y here, and we're going to add 1 to it, and then I'm going to saturate the result, and I'm going to use that for my blending value of the first lerp here. And then for the second lerp, all I have to do is saturate my Y value and pass that into my second lerp. And now I've got a blending function here that's lerping between 3 different color values using a gradient that goes from -1 to 1. So now if I save it, now my blending is a little bit more advanced because up here I've got my sky color, here I've got my equator color, and down here at the bottom I've got my ground color. And just to show you how this is working, let me change my equator color to something weird. Change it to yellow. Now you can see I've got my equator color here in the middle, my sky color up top here, and then down here at the bottom I've got my ground color. And that equator color is pretty important, so let's just paste our original color back. Maybe brighten it up just a little bit. Okay, so I've adjusted my ambient colors here, so I have a nice balance between sky, equator, and ground. Okay, you can see I've got a nice gradient that goes for my sky, my equator, and my ground ambient values. Now it's time to do our diffuse lighting. So let's go ahead and clean things up just a little bit. We're going to set this group of nodes here and group them. And I'm going to call this my ambient lighting. And now it's time to create our diffuse lighting. So what we're going to be using is something called Lambert diffuse. And it's actually very simple. All we have to do to create diffuse lighting is create a dot product between the light direction and the surface normal. So we already have our surface normal coming in here, so I can just wire that into our dot product. There's my normal. I'm doing a dot product between my normal, and now I need my light direction. So I can just bring in the main light direction node and connect that to my dot product. And so what this is going to tell me is the relationship between these two vectors. I have a light source in my scene here. Here's my directional light. And you can see that that directional light is kind of coming from the up and to the left and pointing down here toward my sphere. And so if I do my dot product, let's just go ahead and connect the result of this dot product into our color output here and see what that looks like. So I'll connect that up and save it. And what you can see here is that my sphere is completely black and my light is coming from the opposite direction. You can actually see the sun up in the sky there, and it's coming from the opposite direction. Well, that's a fun feature of Unity, and it's basically the fact that my light vector is going the opposite way. And so to fix that, I just take my main light direction and add a negate node, and that will invert the direction of the light. Then I can connect it up and attach it, and now my sphere is being lit by that light source up there. Okay, pretty cool. There is one thing that needs to still happen though, and it's not completely obvious right now, but what's happening is the result of my dot product is going from a value of 1, where the surface is facing the light, to a value of 0, where the light is perpendicular to the surface, to a value of -1 around here on the back. And I don't actually want my light to go negative. And so what I need to do to fix that in my shader here is add a saturate after the dot product. And so I'll add a saturate here, and that's going to clamp my values, so once they get to 0, they won't ever go below 0. And now I can just connect this up, and you probably won't see a difference here, but what we've done is prevented the lighting from going into the negative. Now you might be seeing this sphere, and there are all these weird looking lines on it. These little gradients here. My gradient is not perfectly smooth. It's running into some hiccups here along the edge. And you might be saying, well, why is that happening? And that is a result of the vertex lighting. That's the quality that we give up by doing lighting per vertex instead of per pixel. Because what's happening is, if you can see these little corners here, that's where the vertices are located. And my lighting is being interpolated from one vertex to the next. So instead of calculating the lighting at each pixel on this sphere, the lighting is only being calculated at the vertices, and then it's being linearly interpolated across those edges. If I turn on my wireframe here, you can see that the lighting is being calculated at each of these edge intersections, and then the result is being linearly interpolated from one to the next. And so we get these kind of these artifacts here of that linear interpolation. Okay, well, we want to go ahead and combine our diffuse lighting with our ambient lighting. And that's really easy. All we have to do is take the result of our ambient and add it to the result of our diffuse. And now we have ambient plus diffuse lighting, and we end up with a result that's a little bit softer. You can see how that gradient that we created in the ambient lighting shows up really nicely here on the back side of the sphere, where the sphere isn't being lit by our direct light. So if we were just using the diffuse light, back here would be completely black. But since we've added in our ambient light, now we have our ambient lighting plus our diffuse lighting. So we get really nice direct diffuse lighting here on the front and really nice ambient light here on the back. All right, let's take this a step further. So the very most basic games wouldn't use textures at all. They would use vertex colors. So when they modeled their characters and their environments, instead of using color from textures, they would just use color from vertices. And so they might take this lighting like this and multiply it by the color of the vertices. So they would just do like a multiplier right here and then pass that in and be done. That would be very, very cheap. But unfortunately, I don't have nice vertex colors created here. And so what I'm going to do is show you what a shader would do if it were the next step up, if they could actually use textures. And so let's go ahead and add a sample 2D node here. And we'll pick our nice cobblestones texture. And all we have to do to combine our texture with our lighting here is multiply the cobblestones texture together with our lighting. And then we can connect that out to the output base color. And now we've got our cool cobblestones. Now, I like to add a little bit of tiling to this. And so I think what I'll do is tile it ×3 and ×2, just so our cobblestones are spaced out a little bit nicer. There we go. So now you can see we've got our nice sphere here, and we've got our vertex lighting, and you can see how it's getting really dark back here. And the reason for that is because we've multiplied our texture by our lighting. Before, when we just had our lighting passed out, it looked nice and bright, but once we get our texture involved, things get quite a bit darker. And that's why you have to be careful that your diffuse texture never gets too dark, because you multiply that by your lighting, and then it's not allowed to ever get any brighter than the darkest pixel here in your diffuse texture. All right, so there we go. We've got our diffuse lighting, and we've multiplied it by our texture, and we have a nice lit model here. Now, there is one more thing that you could do. I've created this texture specifically for physically based rendering, and so it doesn't have any lighting baked into it. But back in the day, we would create diffuse textures with lighting baked into them. And so what I'm going to do here is I'm going to sample the texture that I have that has my ambient occlusion in it. So here I have my cobblestones mask texture, and I have the ambient occlusion here. If we just preview the green channel here, you can see I've got my ambient occlusion. So if I multiply this by my diffuse, I'll get just a little bit more realistic results. So I'm going to take my diffuse and add a multiply and multiply it by my ambient occlusion. And I want to make sure that I tile my ambient occlusion the same as my diffuse texture there. Now we'll pass that in, and this will give me just a little bit more realistic looking results. Now, for ambient occlusion, I would want to do this multiply here in Photoshop. I would want to combine my diffuse texture without ambient occlusion by overlaying my ambient occlusion in Photoshop and multiplying it there. But I've just done it here in the shader so I can show you what that looks like without having to do that. But back in the day, we would never do this kind of math in the pixel shader. We would combine that in Photoshop first. All right, so there I've got my lighting. And if I want to adjust the way that my ambient's working, maybe brighten things up a little bit, I can come over here to my lighting panel again. And maybe just make the ambient light a little bit brighter. Maybe just make the equator color a little bit brighter. And now you can see I've got my dark side and my light side of my model. Okay, so if we review here really quickly, we've created ambient lighting. We've created diffuse lighting. Let me just create a group here really quick. We'll call this Lambert diffuse. And we've calculated that, all of that in the vertex shader, and then passed it to the pixel shader where we multiplied it by our diffuse texture. So that is pretty much the most basic kind of lighting that you can do. And you saw how we started out super basic with just a single color of ambient. And then we went to blending between 2 ambient colors and finally ended up with 3 colors. But obviously you could make this cheaper if you just use 1 or 2. So you have lots of different options there, but that's how you do diffuse lighting. Now some of you might be saying, well, hey, there's no specular highlight on that sphere there. And my answer to that would be, well, specular is going to be a lot worse looking in vertex shading because we already have those artifacts that you are seeing where we are getting the weird interpolation errors around the edges. And if we add a specular highlight here, it's going to get chopped up quite a bit here. Now I am going to show you how to do specular highlights next week, and I might just touch on what those look like in the vertex shader just briefly, but we want to do the specular highlights in the pixel shader so they don't get chewed up by this vertex interpolation artifacting that you're seeing there. All right, so that's it for this week. Let's switch over to Unreal, and I'll show you how to do the same thing in that engine. Okay, here we are in Unreal, and you can see that inside our shaders folder, I've made a new folder here called Lighting. And inside that, I've made a new shader called Vertex Lighting. And we're gonna do vertex lighting here in Unreal, just like we did in Unity a minute ago. So I've opened up my Vertex Lighting shader. And the first thing that I need to do in order to create a shader that does custom lighting is get rid of the lighting that Unreal is already doing. And so the way that I'm going to do that is here where it says Shading Model Default Lit. I'm going to drop this down and set it to Unlit. So now you can see I just get a black result and Unreal is no longer doing any lighting for me. Over here on my main node, you can see that all I've got is here this input that says emissive color. And I can also control a couple of other things, but really the only thing that we're going to be focusing on today is this emissive color input. So if I want to do vertex lighting, the most simple thing that I can do is just create a shader that uses a simple single color. So I'm going to paste in a color here that I've created that represents the color of the sky. And because I want to do this shader in the vertex shader, I have to add a vertex interpolation node. So I'll add a vertex interpolator. And what this node does is it forces anything that's plugged into this left side of the node to be calculated in the vertex shader. So I'm going to go ahead and plug this side in, the pixel shader side, into my emissive color node there. And then I'm going to plug my color into the right side. So now my color is being calculated in the vertex shader, passed to the pixel shader, and then passed out here on the main node. So now you can see I have a very simple shader that basically just has the color of the sky as my ambient light. So the next step that I could do is I could create a little bit fancier ambient light here if I were to use the normal of my sphere to determine what color I wanted to use. So up here at the top, I want to use the color of the sky, and then maybe down here at the bottom, I want to use the color of the ground. So in order to do that, I need to bring in the vertex normal in world space. And unlike Unity, in Unreal, the up vector is not y, it's z. And so I need to create a mask component node here. And I want to use, instead of the second component, the y component, I want to use the z component because that in Unreal is up. So let's just temporarily wire this into our Vertex interpolator. And now what you can see is I've got this nice mask where my up direction is a value of 1 and my down direction is a value of -1. So now we actually need two different colors here. We have a sky color, but I'm just going to go ahead and add in a ground color here for us. And now let's blend between the sky color and the ground color. So I'm going to add a linear interpolate, and we'll plug the sky color into B, and we'll plug the ground color into A. There we go. And now we can blend between these using the gradient that we've created with our normal. But we have a little bit of a problem here because this gradient goes from 1 to -1. And for our lerp here, we need a gradient that goes from 0 to 1. And so what I'm going to do here is I'm going to multiply my normal z component by 0.5. And now, once I've done that, what that's going to do is it's going to shrink my gradient so that it goes from -0.5 to 0.5. And then I just need to add 0.5 to that. So I shift it into the positive range. And now my gradient goes from 0 to 1. So I can take this value and plug it into my lerp. And then I can plug that into my Vertex interpolator. And now I have a gradient that goes from my ground color to my sky color. So I've got a nice ambient there. But I can actually get even more advanced than that. And what I'm going to do here is add in a third color. And this is going to be like my equator color, we'll call it. So I've got our sky color, I've got our like middle color, and I've got our ground color. And in order to blend between these three values, I actually need to create two lerps. So let's create a lerp that blends between my ground color and my equator color. And then we'll create a second lerp that blends between the result of that and my sky color. So we can get rid of this lerp. We'll get rid of these guys down here. And what I need to do first is take my Z component here and just add 1 to it. And then I'll saturate the result of that. And I'm going to plug these results into my first lerp. For my second lerp, all I need to do is saturate the result coming out of here, and that becomes my blend value. So first I'm lerping between the ground and the equator, and then I'm lerping between that and the sky, and I can pass that into my Vertex interpolator. And now I have a blend that's actually blending between three colors. So here I've got my ground, here I've got my equator, and here I've got my sky. So that's what I'm going to use for my ambient value. So let's go ahead and clean this up a little bit. One thing that kind of frustrates me is how big these color nodes are. I wish that Epic would fix this so there wasn't all this like wasted black space in here because these color nodes are just gigantic. What I'm going to do is take all of this and pick Create Comment from Selection, and I'll just call this Ambient. Alright, so that's the ambient bit of my shader. Now I need to create a diffuse. And diffuse is pretty easy. I just need to bring in my light direction here. So I'm going to come down here and pick my sky atmosphere light direction node. And I don't think that Unreal intends for people to do this, but you can use this node as kind of a hack to create lighting in the shader itself, in the material, if you want to. So here's my normal, here's my light direction, and I'm going to do a dot product between these two. And what this is going to give me is a comparison between these two vectors. So if they're parallel, if they're pointing in the same direction, my dot product is going to return 0. If they're pointing in opposite directions, it's going to return -1. And if they're perpendicular, it's going to return 0. So let's go ahead and plug this into my Vertex interpolator. And now you can see that I've got a nice approximation of diffuse lighting. So I've got a value of 1 here where my surface is pointing toward the light source. And I've got a -1 here where my surface is pointing away from the light source. Now, negative light is never good when you're trying to create realistic lighting. And so in order to prevent negative light, what I'm going to do is just add a saturate node there. So now I've got correct Lambert diffuse lighting is what it's called. And you might notice that there are some artifacts here. There's some little hiccups, some hitches in the giddy-up, as it were. And what this is my Vertex interpolation artifacts. If I were to just plug this directly into emissive color, you'd see that those are completely gone now and I have smooth lighting. And that's because this dot product is being computed per pixel. But when I compute it per vertex, it has to interpolate the results across the pixels that make up those triangles. And so that's what we sacrifice for creating, for getting cheaper lighting by doing it in the Vertex shader. We get these interpolation artifacts. And they're not beautiful, but as a result of doing it in the Vertex shader, we get a cheaper cost for the calculation. Okay, so now we need to combine our ambient with our diffuse, and that's really easy. I can just add them together. So here's our diffuse. I'm just going to group this, and we'll call it Lambert diffuse. And we'll add it together with our ambient and pass it out to our Vertex interpolator. And now you can see we're getting our diffuse lighting combined with our ambient lighting. And it's looking pretty nice. We've got a dark color down here, kind of our equator color, and then our brighter color up there at the top. And you can see we've got our nice directional light coming in as well. Okay, so, you know, if we wanted to create a game that was just lit with Vertex lighting and nothing else, we could do this. If we wanted to give our model flat shade, we could take it and multiply it by like a base color. But what I want to do next here is actually multiply it by a texture. So let's add a texture sample node. And I'm also going to add in some texture coordinates here. And we're going to multiply our texture coordinates by a value of 3 and 2. And this is basically, you don't really need to do this. This is just so that the texture will end up looking a little bit nicer on my sphere. All right, so there's my texture coordinates. I'm tiling it by 3 in one dimension and by 2 in the other dimension. And then for my texture down here, I'm gonna grab our cobblestones diffuse texture. And if I just pass this directly into emissive, you can see I've got a cobblestone sphere that is completely unshaded. But what I'm going to do instead is after my Vertex interpolator, I'm going to add a multiply, and we'll multiply our texture sample by our Vertex lighting there. Now we've got some nice, we've got a nicely lit sphere with our cobblestones texture on it. You can see here around the back it gets a little bit darker, and down here at the bottom it's using our ground ambient color, and then here in the front it's a little bit brighter. Okay, now back in the day, this base color texture here has absolutely no lighting baked into it. But back in the day, before we could do lighting in the pixel shader, we actually used to bake lighting into our base color, our diffuse texture there. And so I'm just gonna do this to show you what that will look like. So we need to add another texture sample. And for this one, I'm going to pick my ambient occlusion texture. So there's my cobblestones AO. And I'll just select that. And I can multiply my diffuse texture by my ambient occlusion texture. And I want to make sure that I tile the ambient occlusion texture the same as the diffuse texture there. So now I can just multiply those two together and then pass that in. And what you'll see is I end up with a little bit more realistic looking result because I've baked some of that lighting in. Now, I would normally just do this in Photoshop. Like I'd multiply these two textures together using layers in Photoshop to combine them. So you don't actually want to do this in your shader. You want to do that in Photoshop and then just do one texture sample. But I've done it here just because I wanted to show you what it would look like. But there is our lighting. So if we kind of zoom out here and back up, you can see we've got our ambient light here. We've got our Lambert diffuse light, and we're adding those two together and doing that calculation in the Vertex shader. And then in the pixel shader, we're multiplying the result of our lighting by our texture sample and then passing it out. So there we have it. We have some really nice Vertex lighting using ambient and diffuse. Now, some of you might be asking, well, what about specular? How do I make my model look shiny? Well, you can't really do specular lighting in the Vertex shader because of that, because of those artifacts that we were getting. Again, if we just wire this in and we take a look, you can see that this is jagged, and that's with this really smooth, kind of low frequency gradient that we have. We still get these jagged artifacts. You might imagine if we added specular with a really tight specular highlight, it would look like extremely artifacty. Next week, I'm going to show you how to do specular lighting, and we might take a look at what that looks like just so that you can see it. But I don't want to actually encourage you to do specular lighting in the Vertex shader because it is actually filled with, kind of very ugly looking artifacts. Okay, but anyway, so that is our video tutorial for today. I showed you how to do lighting in the Vertex shader, and we did ambient and diffuse, and then we multiplied by our texture, and now we've got a nice lit model. All right, come back next week for how to do the specular lighting, and we'll see you next time. Thanks for watching, everybody.